Sometimes I forget to start the camera. Again, RStudio is a platform where R sits and aims to offer you a more user-friendly opportunity to talk with R. I suggest that we forget about it now, because I want you to learn the commands, to learn how to use R in the most let's say, inconvenient situation, in the most difficult context. And then, if you want to turn to RStudio, this will be very easy for you. And I suggest you, if you are interested, to also have a look at RStudio. But I don't want at the beginning to make things too much complicated, so let's start with R. Let's start on the console. So we have, as I said, to learn commands, okay? Let's start learning. First, Ctrl plus L allows you to clear the screen. So let's clear the screen. And let's start by typing 2 plus 2, return 4. Perfect. It's already a good start. So we can perform basic operations in R, even in sequence. 2 plus 2 times 3. The result is 8. Why is that? Because it computes first the multiplication and then the addition. So 2 times 3, 6, plus 2, 8. So keep in mind priorities in the 4 operations. If you want to put the addition first, then you have to use parentheses. Did you see what I did? I got back the previous command. How to do that? If you use arrow up and arrow down, you get all the previous commands, including previous sessions, provided you saved. We will see how to save. So, this is very useful, because if you make a mistake and you want to correct the previous, like in this case, let's suppose that I want to change here and put 4, sorry. I can just record the previous one, go back with the arrow, and change whatever I want to change. Now, the power to the power of 3. The power is the at. Okay, this is very easy. You can use an unlimited number of parentheses, so you can write 2 plus 2 plus 3 times 5. Okay, in this case the parenthesis is not strictly needed, but could be needed in this case. So, unlimited number of parentheses. Of course, you have always to close the parentheses. So here, if I forgot to close one parenthesis, what happens if I press return is that the program writes a plus. What does it mean, plus? Like, I'm missing something, give me something more. He's missing a parenthesis. Okay, let me clear the screen again. Now, the 4 operations and the power, it's fine. You can use also fractional power. Of course, you cannot use negative power. No, sorry, negative power is still fine, but if it's negative, I don't understand what he's doing here. I wanted to create an error, but let's forget about it, okay? Because I don't really understand what he's doing. I'm not really sure. Let's forget about it for now. And now, for the 4 operation and the power, this is fine. The problem is that in order to perform additional and more complicated functions, you have to know how to call them, like square root. If I want to use another solution with respect to elevating to 0.5, this is Italian, correct? Yes. So let me try this. Okay, so basically here I used a function that doesn't exist, and therefore I finally succeeded in generating a mistake. So first of all, let me use the correct function. Okay. What did I do here? I used a function. What is a function? Is a pre-programmed operation in R. Like in Excel, you have the same opportunity to compute logarithm, to compute whatever. The function requires you to know the name. So SQRT is the function for square root, name. And then the function requires arguments to be given between round parentheses. So in this case, the argument of the SQRT function is the number which you want to compute the square root. Must be given between parentheses. Okay? If you don't use the parentheses, you get a mistake. Like if I forgot here, you see that there is an error message. Now, let me clear the screen. The parentheses should be around parentheses. If you use a square one, that's not fine. So the correct use is this one. Now, other functions, logarithm. This I think is logarithm with base e. Let me check. Yeah, more or less base e. Yeah. Let's check if it is indeed base e. Exponential of logarithm of 5. Okay. Or logarithm of 10. Yeah, it's in base e. In the above example, here you have an example of nested functions, exponential, a logarithm nested into an exponential. Okay, another function, log 10. Not sure if I will remember. Yes, it works. This is logarithm in base 10. I'm not sure whether it also exists exp 10. No. Okay, this is an example of some of the functions. And of course you may say, you may wonder, how can I know the name of a function? And this is very easy to apply. So let's go to Google. Let's suppose that you want to compute let me think about an additional function like sin. Okay, you search on Google for R project, not just R project, sin function. R, trigonometric function, perfect. Let's go. And you see here, let me increase the size, everything you need. Again, you type the name of what you want to do, compute, sin, function, and then R project, and then click on the first link, and you get to your help page. Okay? Okay, so we can compute sin, of course, is sin of pi, which is 0. Pi is Greek pi. I'm not sure whether Greek pi is a correct translation in English. Pi probably is better. Okay. So whatever function you need, try to resolve it in this way. Okay, now let's move one step forward. We can define variables. A equal 10. And then I can write here A is 10. And I can write A times 2. I can write SQRT. So you can define variables, and you can use whatever name you want with an unlimited number of characters. So I can define my variable equal 90. And then I can write my variable, and I get 90. And this is, of course, very useful. Now, if you memorize several variables, you may wonder what are the variables that I memorized, because you may not remember. So, if you just type ls without any argument, it means list. And it tells you what are the variables that are memorized there. If you want to recall one of them, like my variable, it's just enough if you write the first letter and then you press on the tab. The tab tells you several different options. And why is that? Because the tab doesn't show you only the name of the variables. It shows you names of variables and functions. Very good. So if I put my, now if I press the tab, I get only my variable. So this is useful because if you don't remember the square root, you can just write SQ, and you see that by writing the tab you get SQRT. Instead, if you write log and you press the tab twice, because if you just, when there are several options, just once doesn't do anything. You have to insist twice, and you have all the alternatives. And here you don't see the logarithm because I think it doesn't display all the alternatives because it doesn't. I should move on the right, but it's not possible. You see that on the right there is something missing on the screen. I should probably do like this. No. Anyway, if I do log, then I have all the alternatives with the log. This use of the tab is extremely important because it allows you to save time. When you use a software like R, or Excel or MATLAB, during one day, 8 hours of work, you may perform like 2,000 operations. Or let me use a number that is significant. You may perform 3,600 operations. And if you save 1 second per each operation, at the end of the story, at the end of the day, you work 1 hour less. This is really a meaningful example because it makes your life much easier. So, again, I want to stress the concept that you need to be very efficient, and therefore the use of the tab allows you really to save a lot of time at the end of the day. Okay? Okay, now, let me clear the screen. Now, I have these variables that are saved. Sorry, this is a mistake. If you want to recover after a mistake, if you press S, you get back to the console. So I have these variables, as I said, but I have more in the memory of the program. I also have the previous operations. You see, I'm going back. So at a certain point, it may be useful that you save this information. like in Excel or in Word, after a certain time you save it. First of all, here, no, not first of all, let's take into account that here we have an additional reason for saving the information. The reason is that you can't undo. I mean, if you make a mistake, like, let me remove a variable. RM means removing. I press return and then I say, oh gosh, I didn't want to remove it. There is no way to undo. Okay? There is a way of redoing. Redoing means I go back with the arrow to the definition of A. So I can redo. And this is something that in Excel you can't do. In Excel you can't redo. In R you can redo, but not undo. So a good reason for saving, a good additional reason for saving. Now, how to save? Usually what I do is quitting the program. Q means quit. And when I press return, it asks me, do you want to save your workspace? Yes. And then I can start again. And if I start again and I go back with the arrow, you see that there is everything there saved. Let me change the font again. So this is what I usually do for saving. It's not very efficient because, you know, to go out and go back, it's not very efficient. Also, if you make a list, I have the variable. Now, another question from you could be, okay, let me learn how to save without quitting. No problem. Let's look for a function that allows you to save. And you see two options that are interesting for us. Save image. And this means that you saved the variables, the workspace. You didn't save the history. And the second is save history. Okay, without any argument, and you saved it. In fact, let me try to check if it is true. If I quit and I decide not to save, it should anyway have kept the comments that I gave before. Let me again change the preferences. Let me see if I have a save history in it. You see, the last is save history. History was saved. Okay, good. It is also possible to save the history in an external file, but let's forget about it for now. Okay? Now you have to know that if you want to save everything, you have to comment. Save image, save history, without quitting, or otherwise you quit. Okay? And another question could be from you, okay, I saved it. If I want to take these files and transfer them to another computer, how should I do? Okay, let's forget about it for now. You don't need it because you have your own PC. Okay? Okay, good. So I learned how to memorize variables, how to use functions, and how to save things. Good. Let's move forward. Let's see how to plot. This is another very important thing that we have to learn. First, before learning how to plot, let's learn how to store vectors. We learned how to define variables. Let's see how to define vectors. Okay, so I can define A equal, be careful, A is the name of a previously stored variable. If I assign another variable or another vector or another whatever to A, it will delete the previously stored information without telling you. This program is a high-level program. High level means that it's not advising you anytime, like, look, you have left the door open, you may feel like you get cold in the room, so it doesn't give you alerts for everything. Windows is very user-friendly. It tells you a lot of alerts. Like, are you sure you want to go out? Are you sure you want to delete this? Are you sure you want to... In this case, it doesn't tell you much of these things. So if I say A equals 0, A is 0, without telling me anything, without telling me there was a previous A. Look, the fact that it doesn't give you a lot of warnings, it's not unintended, it's intended, because any warning is a waste of time. So during a day, if you get 100 warnings, and you spend 3 seconds in reading the warning, you spend 10 minutes reading warnings, and which is not required for a high-level use of a program. So, let's define a vector. There is a function for defining vectors. The function is simply C. And then let's give the element 0, 0.1, 0.2, 0.3, 0.4, 0.5. Now, what happens if I recall A? I get the vector. And what happens if I compute A times 2? I get another vector where each element of the previous vector A is multiplied by 2. What happens if I compute A plus 2? Just try to play and you understand how R operates with vectors. Now I am interested in plotting this vector. Plot A. And you see what happens here. Try on your PC. Basically, I got a plot of the vector where I have the index in the abscissa and I have the element of the vector A in the ordinates. Very good. The only thing is that it's barely visible, not really nice to see. Let me go back to the console, and in order to go back to the console, I can minimize the plot window. And let me try to explore how to make these dots bigger or red in order to make them more visible. So the question is, how to make the dots bigger? First question. How to do that? Let me get back the console. I think it is no. Let me see. Okay. How to do that? I don't know really. So I have two options. Either I go to Google, like plot options R project. This is a first possibility. Let me do it. Just 1 second. Okay. R project, plot options. Okay, quick R, graphical parameters. This is a bit complicated, but let's explore another option. So this is a possibility. I studied this web page. Okay? Okay, good. But let me explore another options. Question mark, plot. Let's see what happens. Look at what you got here. It's an help page for the function plot. Let's look back. How did I obtain it? Question mark, name of the function. Of course, you need to know the name of the function. So if you don't know the name of the function, go to Google and try to Google what you want to do. If you know the name of the function, don't go to Google. It's much quicker to type the question mark and the name of the function. Now let's look at the name of the function. The help is quite long because why it's quite long? Because plot is a high-level function now, which has a lot of options. I tell you, in R you can make drawings, plots that are much more detailed and much more flexible with respect to what I do with Excel. And this is a good reason for learning R. When you produce output for your customer, your client, that's fine. In Excel you produce very nice plots. But if you can do some more, and maybe in a quicker way, this is a good plus. It's something that allows you to be very competitive. It's a good reason for learning some additional skills. Okay? And I want to show you, this is not easy, but let me show you an example of a figure that I made with R, for instance. Not really easy because I need to give me 1 minute. I need to go to my website and let's look at this. Let's look at this and let's look at I think this one. Let's see. Just 1 second. Okay, this is a picture that I made with R. Let me see if... Okay, let's forget what it's about. And let's forget what it's about. And anyway, it's a revolving picture, an animated picture. It's nice. Okay. Okay, it's nice. I'm not sure you agree, but let's say that it's okay. Okay, and let me look to another one. Just 1 second. Here, this one. This is another animated picture, and which allows me to put a regression line that is moving along the data. And this is done with R as well. And let me see, because it's not okay. And another very good feature that R has, it's not used in this case. You can put the labels wherever you want. In Excel, you can only use equispaced labels in graphs, like here. They are equispaced every 10 years. In R, you can put the labels wherever you want. So if you're interested in 1953, you can put 1953 there. Okay, and this is something useful. But let me go back to the main point. Plot is a high-level function. Okay, so let's go back to dev, and it's not easy to find out the information in a long help I need. My needed information is how to make the dots bigger. So let's try to scroll down, and here you see, for instance, what type of plot should be drawn. Possible type are P for points, L for lines, etc. And so let's see whether there is something else. Okay, let's click on PAR, graphical parameters, and let me see if I can find okay, let me try to use this one, GEEX. Plot A, I'm not sure, CX equal to 3. Okay, let's look at what happened. Okay, you see I got it. Of course, I got it because I knew where to look at. But basically, I went to the help of plot. I saw that there was a link to graphical parameters. I clicked on the link and I found CEX. It's a magnifying factor. And then there are graphical parameters for filling the dots, for instance, etc. But there is another thing that I wanted to try, which is this one. Type equal line between double commas. So let's see. You see that the plot became a line. Let me give you other examples. Type equal line, col equal red, line width equal 3. Let me try to restore it. Just 1 second, I try to put together the graphical window and okay, here we are. L is line, type line.
No,
Line width. Line width. Now, let me add something else. Xlab equal to, you see what I changed the label of the axis. Now you don't see anymore the Xlab and Ylab are the labels of the axis. Okay. Now, so there are a lot of parameters that you can use in a plot, and one important thing before we move to something else is how to display. This is a plot that is an histogram. How to display an XY plot. This is an histogram because the argument of the plot is just the vector A. And in fact, if you remember, what is displayed here, it's index. The default label for the abscissa is index. This is an histogram actually. Histogram means that these numbers are equally spaced. But sometimes we need to plot a function like an xy plot. So let me define another vector like b, and b may be equal to c, like 10, 7, 12, 11, 25. 5 elements. And then I may plot, let me just do this. I may plot A, B. So A counts 6 elements, B counts 5 elements. So let me redefine B. I redefine B, and let me now plot AB. So this is the plot of AB, where A is the abscissa, B is the ordinate. Okay. So basically we already learned how to play with numbers, functions, how to plot the results. We are at a quite good stage, and also we learned how to save it. Okay, now let's make an important step forward, which will take to us about not half an hour, but 20 minutes, yes, probably. How to upload data. This is basically, it's basic for us. So, for now I uploaded data by just typing, but sometimes we have to deal with like 100 years of wave data. And it means that maybe, or 100 years of whatever, it means that you may have like several thousands of numbers to put into the PC, and you can't type all of them. So basically what you get, in this case, frequently what you get is an external file providing the data. And you have also the same problem in Excel. In Excel,